This work title is a unified experimental framework for comparative evaluation of deep learning models in COVID-19 lung lesion segmentation. COVID-19 lung lesions remains a challenging task for reliable diagnosis. As of 2025, the World Health Organization has reported over 700 million confirmed cases and nearly 7 million deaths globally. Imaging testing, such as computer tomography, is employed for the diagnosis of the disease. To the best of our knowledge, this is the first work that proposes a unified experimental framework designed to evaluate deep learning models for the segmentation of COVID-19 related patterns, focused on ground glass opacity. The proposed method begins with dataset selection and preprocessing, using public data recognized in the literature as reference dataset. The second phase involves selecting models based on code availability and the diversity of architectures developed between 2020 and 2025. There are 5 selected models: DAPSenet, MISNN, MEDPSEC, MEDSAM, and MEDLSAM. The model evaluation framework involves the performance analysis on the following aspects. Quantitative segmentation performance involves using metrics such as dice score, intersection over union, and pixel-wise precision. These results were also tested out again with the Kruskal-Wallis test to evaluate whether there are significant differences. Model complexity and efficiency is assessed by evaluating inference time and model size. Model prediction agreement includes a correlation matrix to measure the degree of agreement between the predictions of different models, along with a dendrogram to visualize the hierarchical clustering. Pixel-wise analysis involves using the metrics of mean absolute, mean overprediction, and mean underprediction errors to measure the average absolute difference between predicted and actual pixel values. Within a scatter plot, a threshold line divides the two x's, with points above the line indicating optimistic behavior and points below the line indicating pessimistic behavior. Interpretability is evaluated using GradCam attention maps to visualize the regions where the models focus during inference. The results show that MEDPSEC, despite having the largest number of parameters, 54 million, has the shortest mean inference time, 160 seconds, and is the most consistent model across datasets. By computing pixel-wise prediction, we identified 3 clusters for the models. The first cluster was composed of MEDSAM and MEDLSAM, the second cluster MISNN and MEDPSEC, and the third cluster DAPSenet. The most optimistic model tends to double the rate of false positive pixels in computer tomography scans. Pessimistic models tend to increase false negatives for the negative class at a pixel level by approximately 50%. The analysis of attention maps revealed that false positive pixels were predominantly located near anatomical boundaries, while false negative pixels tended to occur in regions with subtle or low contrast lesions. This unified evaluation framework of COVID-19 lesion segmentation introduces 5 aspects for model analysis, classifying models as optimistic or pessimistic based on false positive and negative rates, providing a foundation for future work. Thank you.